Good morning, students. So, dear students, I am Santan, working as a physics faculty in Target English Medium School. Today, in this part 2 video, I would like to explain about what is the pressure difference and what is the pressure acting on a body when it is immersed in a liquid is nothing but what is the pressure acting on a body when the body will be kept inside the liquid at its height, and what is the difference in the pressure is acting on the upper portion and lower portion of a body. These concepts we discussed in the chapter of from the chapter of floating bodies, mainly from 9th standard level. So, in our previous video, we are clearly discussing about what is atmospheric pressure and which device we are used to measure the atmospheric pressure, that is called Torricelli. So means barometer. Who invented the barometer? Torricelli scientist. So based on the barometer concept, we have discussed 2 or 3 important points. I says that empty space will be found in the barometer at the sea level in normal atmospheric pressure. At that time, the empty space formed in barometer, empty space formed in barometer is called Torricellian vacuum. It is important for that purpose. The empty space above the mercury level is formed in barometer is called Torricellian vacuum. Because of who invented the barometer? Torricelli scientist. That's why the empty space created or formed above the mercury level in a barometer is called Torricellian vacuum. So generally, what is the SI unit of pressure? Pascal or Newton per meter square. 1 Newton per meter square is equals to 1 Pascal. We know very clearly how much atmospheric pressure is acting. So 1.01 into 10 power 5 is nothing but 10 power 5 Pascal. But in meteorological department, the atmospheric pressure is measured in another units, that is called bar. That's why 1 bar. It is a which unit? Meteorological unit. Listen very carefully. So bar is the meteorological department. Meteorological department means we know very clearly. So the department which is given by the weather information means at what time. So what is the temperature of the weather, and and one more thing is also means simply the meteorological department will be give the information to us about the changing in the weather, mainly based on the barometer. That's why 1 bar is equals to 10 power 5 Pascal. 10 power 5 Pascal. And torque is also another unit. 1 torque is equals to 101 325 716 sorry 706 1760 means 760 sorry. So 101 325 760 Pascals. So 1 bar is equals to 10 power 5 Pascal, that is equals to 180 m we are called Okay, 1 torr is equals to 101.325760 pascals. Uses of barometer. What are the uses of barometer means? Mainly two uses discussing in this time. One is barometer is used as a altimeter. So listen very carefully. Barometer is used an altimeter. Altimeter is nothing but to measuring the heights. Is nothing but so aeroplane means an aeroplane will be moving above the surface of the earth at what height. Okay, that is easily we are find with the help of the which one altimeter. I will explain laterally in this video. It is used to knowing weather forecast. So it is also used for knowing the which one weather forecast. So means what type of changes will be occurs for the next 24 years in the weather. So it's nothing but rain will be occurs or not. Okay, if it is a cyclone or normal rain, what is the humidity present in the atmosphere? This type of information was we can easily find by using the barometer. That's why I said very clearly. So the meteorological department or use the barometer, and with help of that one they give the weather forecast in the TVs and news channels. We are observing papers. We are observing that they give the weather information. How they gave the weather information? Even though in our smartphones weather app is there, we can tap open the weather app. They give from in a day from this time to particular time, from morning to evening, and next coming 1 week also they give what is the temperature in the atmosphere, maximum, minimum. It is the cloudy day or non-cloudy day or windy day or not. Like this type of information you are observing. How they give this type of information or how they can predict it? So with help of which one? Barometer. So in a barometer, the level of the mercury is slowly decreases. Listen very carefully. In a barometer, the level of the liquid is slowly decreases. It is represented in the next coming 24 hours. Rain is occurs. If the level of the mercury in the barometer suddenly fall, it is represented. Coming the next 24 hours, a cyclone will be occurs. So listen very carefully. So the mercury level is gradually fall, means gradually decreases in a barometer. It is represented in the next coming 24 hours, maybe rain is occurs. While the mercury level in a barometer is suddenly fall, it is represented or it is gives which type of information to us. So in the coming next 24 hours, a cyclone, maybe a cyclone will be occurs, that is in that particular area. So listen very carefully. Barometer is used as altimeter, is nothing but to measuring the heights, and barometer is used also to knowing the weather forecast. And with help of the barometers, the barometer liquid is slowly gradually decreases. It is represented in the coming 24 hours, maybe rain is occurs, suddenly fall, it is represented. Maybe a cyclone is occurs for the coming 24 hours. So now we are going to another topic, that is one. pressure acting on a body, pressure acting on a body inside the liquid. So listen very carefully. What is the pressure acting on a body when the body is placed or kept inside the liquid just beneath the surface and at the middle of the liquid, like that type of concept we are discussing in this topic. Okay, so our topic is pressure is acting on a body inside the liquid at a certain depth. So in this one, generally, pressure acting on a body inside fluid. Inside the fluid. So listen, pressure acting on a body inside the fluid. Fluid is nothing but either liquid or gases. Is easily measured by using a device. That device name is called manometer. Listen very carefully. Atmospheric pressure is measured by using a device. That name is called barometer. So barometer is nothing but atmospheric pressure. Okay, but what is the pressure is acting on a body when the body will be keep inside a fluid is nothing but in a gas or in the liquids. Okay, at that time how much pressure is acting on the body? For example, one iron object or any material of the object we can keep inside the liquid or we can keep inside the gas, like that one. At that time how much pressure is acting on the body we can find easily with the help of which one? Manometer. That's why manometer is a device. With help of this device we can find easily what is the pressure acting on a body inside the fluid. So, under this concept, what is the pressure acting on a body inside the liquid? So, two cases are there. Now we discuss it. Okay, each and every case. Case 1. The body is inside the liquid just beneath the surface of water. Just beneath beneath is nothing but under the surface of the water only. Okay. So it is a transparent glass trough. First of all, we can take a transparent glass trough. It is filled with water up to certain level. That's why this horizontal line is represented the surface of the water. Now here we are consider a cylindrical shape of the liquid column. So which one we are considered here? Which one we can take in this one? So in the trough we are taken the water. That's why. So now just you are imagine one cylindrical shape of the liquid column of water just beneath the which one surface. Beneath is nothing but just below that one only, nearest to that. Okay. So that's why just it is an imaginary part. Listen very carefully. It is an which type of part? Imaginary part. Or otherwise, okay. So for other one, instead of the liquid part, if you can take the other density of the object, what will happen? That is we discuss later in this time. First of all, so first we can take an empty transparent vessel. It is filled with water up to certain level. After that, now we are imagine one cylindrical column of the liquid just beneath the surface of the water at any position. Now here, this is the cylindrical part. At that time, we draw the dotted lines. These dotted lines are represented. What is the shape of this one? It is a rectangle is nothing but in three-dimensional cuboid shape like that one. You can see here A, B, C, D. That is one is there. Now we know that. So its surface area is A. Its surface area is A because of it is the unique one. So that's why we know that atmosphere is nothing but the blanket of air present in the air is present in the surface of the earth is called atmosphere. Listen very carefully. So the air is surrounded by our planet in type of a blanket mode. So that is simply what we are called atmosphere. Or our planet is surrounded by a blanket of air is called atmosphere. The atmosphere is nothing but simply we are called as air. The air will accept the pressure or not? Yes, it is accept the pressure. In our previous video, I clearly explained. And what is that value? H rho g. We do know very clearly. That's why. So on this area of the liquid, on this area of our liquid considered column, so atmospheric pressure means air pressure is acting on this one in vertically downward. So that's why P naught is nothing but atmosphere. P naught pressure is acting on this area. So next in the downward, so we know that the fluids will be having a buoyancy force. Mainly in case of liquids, we are observing very clearly. That concept we discuss laterally, but I give a small information to you in this time. Now, for example, if you can take one spherical shape of hollow bar, large size of the hollow bar. Now it will try to immerse into a bucket of water. You are observing that when you can immerse into the bucket of water, at that time, so you feel some force is acting on your hand in vertically upward. Is it correct or not? When you try to immerse the ball into the water, at that time you feel that through your hand some force is acting on the ball in vertically upward. That force is called, what is that one? Buoyancy force. That's why we know very clearly pressure is equals to force upon area. Then force is equals to pressure into area. Transfer to this way. That's why here what is the force is acting on the upper surface means P naught A. What is the force is acting on the lower one by the liquid due to its buoyancy force PA. P is the pressure accepted by the liquid. A is on surface area of the object. Now at the same way, so what is the liquid column? We can say that on this liquid column is pulled by the earth gravity to the downward or not. That's why the weight of the liquid, the weight of our considered liquid column, we can say as a W. This weight of the liquid or this mass of the liquid is pulled by the earth gravity. That is called weight of the liquid. So listen very carefully. Some points we are considered in this topic. What is that one means? Okay. So atmospheric pressure is acting on this area A. That is called force. Means air force is acting on the AB. And so at the CD surface A. So liquid is exert some force in vertically upward. That is called buoyancy force. So that's why, so on the object, two pressures will be acting. Atmospheric pressure is acting downward and liquid pressure is acting vertically upward. But instead of the pressure, simply you can set the force. So the atmospheric force is acting on the AB in downward direction and liquid buoyancy force will be acting at the CD surface in vertically upward. That's why totally on our considered liquid column, how many forces are acting? Mainly three forces will be acting. One is air force is vertically downward, buoyancy force is vertically upward, and earth gravitational force is also acting vertically downward on the liquid concerned mass of the body. That's why. So here mainly you can say that. Okay. P naught A is acting, P naught A and weight of the liquid in which direction? Downward direction. So P naught A means the force exerted by the air on this one in this particular area. That one and weight of the liquid column. Both are acting in which direction? Downward direction. That is the first one. And PA acts vertically upward. So P naught A and weight of the liquid acts vertically downward direction or vertically downward, and PA acts vertically upward. That's why totally three forces will be acting on this one. Air exerted force is acting downward, buoyancy force is acting vertically upward, and the same way gravitational force is also acting vertically downward. Two forces will be acting downward, one force is acting vertically upward. But anyway, so the liquid, our consideration of liquid column just beneath the surface, it is in which position? Equilibrium position. Equilibrium position is nothing but what are the total forces is acting on the body in downward and upward direction. All are equal or same. It is nothing but the force exerted by the air on the AB surface in vertically downward and weight of the liquid column in vertically downward. These two are equal to which one? The buoyancy force is acting vertically upward. Why? Because of it is in which position? Equilibrium. Equilibrium means it is not moving either upward or downward. Still, it is in rest position. That is the meaning of that. So that we are observing that here, according to Newton's laws, according to the Newton's laws, so these two forces are two downward forces, one upward forces. These two downward forces are equal to which one? According to which law is valid here? Newton's third law. To every action there is equal and opposite reaction. Then what will be happen here? P naught A and W, these two are acting on this our considered liquid column in vertically downward. But the body will not move to downward, still it is in the rest because of some forces. PA is acting on the CD in vertically upward. That's why P naught A and W, these two forces are balanced by which one? PA. That is the meaning of that. These two are acting downward, it is acting vertically upward. That's why what we know that according to the Newton's F of AB is equals to F of BA. Direction is negative. That's why F of AB means here P naught A and W, these two are the A body. These two forces are acting on the body in vertically downward. But PA is acting in direction opposite direction. That is one. So that's why, according to the Newton's third law of motion, what we can write that PA is equals to, okay, P naught A plus W. Here we don't consider the negative symbol. Negative is represented only the direction. That's why PA is equals to P naught A plus W. These two are acting downward, it is only acting upward direction. Then next, PA is equals to P naught A plus W is nothing but weight of the liquid. So weight of the liquid means we can write simply mg, because of W is equals to mass into acceleration due to gravity. Pa is equals to P naught A plus mg means here we are consider the density of the liquid column also. That's why we know very clearly rho equals to mass upon volume. That's why in this one what you can write in the place of mass. So V is transferred to this side. Rho V is equals to mass. That's why rho V G we can write. So then PA is equals to P naught A plus rho Vg. Rho V is nothing but volume. What is the volume of the cylinder here? Based on our imaginary this one. What is the shape of this one? It is a cuboid shape. In 2 dimension rectangular shape, in the 3 dimension cuboid shape. That's why what is the volume of the cuboid? Length into breadth into height, or area into height. That's why V we can write as area into height. So that's why you are observing that left hand side and right hand side, which is the common. Okay, so in the right hand side, A is the common factor. That's why PA is equals to A of P naught plus H rho G. That's why A get cancelled. Okay, so what is the remaining one? P is equals to P naught plus H rho G. So this is the formula to find what is the total pressure is acting on our consideration liquid column. Consideration liquid column. Okay, so just beneath the surface, that is one is there.